We're going to take a look at number 63 from section 1.7, which is on inequalities. The problem reads 2x squared is greater than or equal to 3 minus x. As you're reading through the problem, what you should notice is that one of your terms has an x squared, one of them just has a term with an x, and the other one, and your other term, has a constant. From here, what I would suggest doing is note that maybe these are familiar components of a quadratic. So I'm going to add x to both sides and subtract 3 from both sides. This is going to allow me to cancel these values out, and this provides me with 2x squared plus x minus 3 is greater than or equal to 0. So now I've kind of removed that layer, I've rearranged things and revealed this quadratic, so it looks slightly familiar now. So once you have a quadratic, hopefully your knee-jerk reaction is to say, well, I wonder if I can factor it. So if we had 2x squared, I know I can break that into 2x and x. And then I have to decide how to split apart this minus 3 right here. And what I want to note is that whatever values I place in these binomials, they need to multiply to give me that negative 3. But when I FOIL it out, when I FOIL out, so the outer and the inner portion of the FOIL, I want them to add to a positive x. So I'm going to go ahead and try to do a positive 3 here and a minus 1 here. Okay, remember, if you're not sure if you did the work correctly, you can always do a quick check. And we check by foiling, and if we foiled this correctly, we should arrive back at our original problem that I have denoted in orange here. So we would get 2x squared minus 2x plus 3x minus 3. And if we were to combine like terms, we do get a positive x, so we are okay. Okay, so when we continue this problem, we are going to essentially note our restrictions. So we're going to take 2x plus 3, set that equal to 0, as well as x minus 1, and set that equal to 0. And then we solve for x. So what I would suggest doing is maybe pause the video, or maybe you've already solved the problem. So what we are doing is we've established some boundaries to work with. So we're going to put our number line in here, and then we're going to note where negative 3 halves would fall with respect to where 1 would fall. Okay, and then we also want to ask ourselves, do we want to use brackets or do we want to use parentheses here? And go ahead, take a second to think about that. And if you answered brackets, you would be correct. I'm not quite sure which way I'll be shading yet, so I'm just going to note where the brackets will fall. I may have them oriented in the wrong direction. Okay, so now what we're going to do is we're going to check by picking values from each section. So the first section that we're going to take a look at will be to the left of negative 3 halves. So we just want to pick any value. Odds are you want to pick something that's small and probably closer to the value, just because it's going to be easier to evaluate and it's going to open you up to less opportunities for making an error. So if we were to go ahead and check it, you can either check it with your original problem or this problem or this problem, because essentially they're all the same question. I've just manipulated them a little bit. So I'm actually going to work with the center one here. So I'm going to put a negative 2 in everywhere that I see an x. And let's check this. So go ahead and do the work right along with me. I'm probably taking too many steps. So in this case, I have 3 is greater than 0, and that is a true statement. So I'm going to go ahead and shade this part of the number line. So what I've been told is a truth. So all the other values that I would pick to the left of -3 halves, that's telling me that it would be a true statement. So we can go ahead and do the same thing. We would want to pick a value that's between -1/2 and 1. And odds are you can probably already guess if this is going to give you a truth or a lie. So we have 2 times 0 plus essentially 0 minus 3. This becomes 0 plus 0, which minus 3. So here we arrive at the conclusion that -3 is greater than or equal to 0. And obviously this is an error. That's a lie, so we wouldn't use it, and therefore we would not shade the area in between. Lastly, we would then go to pick a value to the right of 1, and we will go ahead and say pick 2. Of course, you don't have to do that with a 2 if you don't wish. We get 2 times 4 plus 2 minus 3 is greater than 0. This becomes 8 plus 2 minus 3. And then we get 7 is greater than or equal to 0. This, again, is a true statement, so that tells me that I can go ahead and shade this. Alright. So the last thing that we want to do is we want to present this answer in interval notation as well. So the way that you have it set up, we actually can just start dropping information down. So I know that the shading is going to go off into negative infinity. Make sure that you recall that the negative infinity will always have a parenthesis next to it. You would never have a bracket there because negative infinity is not actually a number. It's an idea of a number. So, for example, if you were to ask someone what's the smallest or largest negative number that you would be working with, odds are, once they give you the value that they think that is the largest negative number, you in turn could go a little bit further. So it's just an idea, so we can never actually use infinity. It's just an idea of a number. And we're going to take this up to the -3 halves and then include the bracket as we have indicated on our line. And since we have this blank area, in other words, the area where we would only get untruths or lies or false statements, we want to connect it with the next interval. So that would be including the 1 and going off into positive infinity. And again, that positive infinity will have a parenthesis next to it. So here are your final solutions. And that's it.